the final heater PCBs just arrived, and there's a couple of silkscreen issues. I last minute kind of moved two of the connectors, you know, one connector here and somewhere else too. I know there were two of them. Oh, and the temp, I flipped the sides on them. So these both got blasted a little. It doesn't matter, it's not gonna affect anything. So there's the temp one that got blasted and this one. This is why you don't change PCBs last minute, but whatever. They're gonna work just fine. One of the things I added on here from the previous version, this was the previous version of it, I took away some of the text, but I added this little graphic here so that you can align the temperature sensors properly when you're installing. There's a little piece of gap pad that has to go on them. And so this will be a really nice lineup, and that'll be in the videos when we get to it. But basically, this fixes the issue on the 18S configuration where the wires were running into the fan shroud. And the way I did that is that I added this high voltage interconnect, and it has basically a right angle 2-pin connector on it. You can see it right there. And when you are using, oh look, that got blasted too. Well, I have some silkscreen issues, but whatever, I don't care at all. Basically what this is going to do is on the 18S configuration, you will plug an interconnect between the two modules. So the 18S has two modules like this, and you will plug on the 12S module here to the middle module. There will be a wire jumper from there to here, and then on the 18S you'll jump from there over to there, and that'll be a very short cable because this is a very limited space. This is between LiBCM and the modules. Now in the 18S configuration, we don't have this issue. So in the 18S you will basically route both of these over to there, and that's why there's a 6-position connector and not a 4-position connector there. And then you just won't use the interconnect. So you'll either use the interconnect on this further module, or you will connect it, just depending on if you have a plus minus or the minus configuration. Now, funnily enough, this package that was lost finally just showed up, and you know, way late. I mean, I've got the other PCBs, so I won't even ever use these probably, which is unfortunate because there's a little bit of waste there, but whatever. Yeah, so this should be the final board. Of course, I'm going to build it up. These boards came really quick, and so I don't even actually have the final resistor value here, which is going to be 3.9K, so all these resistors will be 3.9K. Right now I have, I think, 2.5 and 2.4K, but I'm using like an external lambda gen power supply, so I'm not using the full 48S, you know, the 200 volt, 190 volts or whatever. So I can set that lambda gen in my testing to whatever, say 130 volts, and that gives me the same amount of power. And I'm going to be doing that. I'm going to build these up with those old resistors, even though the new ones will be here in a few days, because the low here on tomorrow night is 7 degrees Fahrenheit. And that is unseasonably cold here. So I'll be able to test these outside to make sure that I can heat up to, you know, 35 or whatever. So I'm going to build these up tonight and be ready to go so that tomorrow I can put this outside before it gets really cold. And that'll be a full, I'm going to put it all on the pack and everything, build it all up. And now that I have these temperature sensors on each module here, I'll be able to monitor that temperature without having to take the pack apart each time. Now, of course, I will still take the pack apart to make sure that the temperature agrees here with the actual temperature that I measure with the thermal imager. But yeah, so that is that. And then with any luck, I'll start shipping these next week. It is the Christmas holidays, but actually this year I am not doing anything for them. So my wife is going up to see her family, but we were actually just up there, and she told me I got a pass, so I didn't have to go to this one, so I'm not. And so anyway, I should be working on this. I should have a solid week of time just to work on this. Get that, well, you know, LiBCM in general. So get these out before I mix them all up. Other thing I want to talk about has nothing to do with LiBCM. It's what I've been working on the last several days now, and I just kind of want to talk about it as an engineering gotcha or whatever. So we sell a product that uses this circuit board, and we've sold lots of them. I don't even know, 37,000. I have no idea. I don't even know. I don't keep count anymore. But anyway, we had a FET that was out of stock, and so we bought it from I guess a less than reputable dealer. And yeah, that's the way the market works now. And of all the things, we had an issue when the device was turning on. It has a large inrush current, and we know that inrush current. And if it gets too high, it trips and turns off or whatever. And we were seeing this, and it went from 0%. We'd never seen the issue, and we've been shipping this for 2 years now, and this particular revision of this hardware. And we went from having 0% of this issue, never seeing it before, to like 6%. And like on day 1 it was 6%. On day 2 it was 30%. On day 3 it was 50%, and then on day 4 it was like 100%. And in addition, it only has the behavior when a firmware update that we just released last month is installed, because that firmware update basically makes it more powerful or whatever. So we kind of had all of this perfect storm of about 10% of our units in the field appeared to have this issue after the firmware update. This is kind of why I had to drop everything last week towards the end of the week and just kind of work on this issue. It was actually very challenging to figure out what the problem was, because to me it was like, oh, we had this firmware update. Well, duh, it's the firmware. It's not the firmware, but I got to where I was even swapping the actual ICs on these boards, because I was convinced it was the firmware, but I couldn't find anything in the firmware that was problematic. And ultimately, at the end of the day, it's that the FET that we're using is not the correct part. We're supposed to be using the IRFH 5406, and what we purchased was, or what we received was the IRFH 5006 instead of 5406. It was 5006, and those parts, because of the way we characterize this, the incorrect parts actually have lower RDS on, but they have much higher gate capacitance, and it was causing our overcurrent circuit to think there was a short circuit when there wasn't, because these FETs are switching 60 kilohertz or whatever, 30 kilohertz, just depending on what's going on. And anyway, this is kind of what I did Friday, Saturday, and Sunday. And the last annoyance here, another annoyance with FedEx. I've been ripping on them a bunch. FedEx is horrible. This was basically, I had work send me 3 more of these, because they sent me 1 and I broke it, whatever, trying to figure out what was going on. And then I was like, cool, send me 3 more, overnight it. So they sent it, and it was supposed to be here at 10:30 a.m. on Friday, and it did not arrive. And then it was supposed to be here at 10:30 on Saturday, did not arrive. And then Sunday, I figured probably won't arrive. And then Monday, it shows up Monday at like 11 a.m. So 4-day shipping. It was $120 for shipping, and it was supposed to take 15 hours to get here, and it took 4 days. None of this has anything to do with LiBCM, but it has been what I'm working on. So fortunately, this issue is fixable in firmware. I haven't fixed it yet. So right now I'm we know what the problem is, and so we say, for those 10% of the machines, we know what the problem is now. There will be a firmware update, but it hasn't happened yet. So 10% of our customers are using the old firmware. Of course, we stopped using the FETs that we received that were incorrect. And man, it still blows my mind that it was the FETs here. This is screaming firmware or counterfeit ICs, or rather counterfeit microprocessors, because we have 2 of them on here. Anyway, lots of soldering and desoldering. My hot air rework station here got worked pretty hard this weekend. I hardly ever use this, but for this board, it's 4 layers, and there's a lot of full fill planes, and I had to remove all these FETs. And anyway, again, nothing to do with LiBCM, but it has been what I've been doing. It's slower now because we know what the problem is. And so I am going to have to fix that firmware. I don't know how I'm going to fix it yet, but I know it's possible in firmware to fix that. I'm going to have to basically change the control strategy. Nothing to do with LiBCM. But what I am trying to say, talking about it here, engineering problems are difficult sometimes, and sometimes they're very simple things, but more pertinent to LiBCM. This is a more important thing, because at the end of the day, this is the bread and butter. LiBCM is definitely not. It's the passion project. So I am going to be working on this some until I can figure out what the firmware needs to be. The cool thing is the behavior is 100% reproducible, so I'm not like chasing phantoms here. So I have scope captures of what the behavior is, and so I should be able to fix that in firmware. I'm just gonna have to think about it. So anyway, as always, thank you for watching, and I hope to get these finals. Well, this is the RevA, but no, this is the RevB. I hope to get these shipped, starting to ship next week. I think so far only 4 people have signed up for it, so I can definitely build 4 complete sets of them. That will probably take a couple of hours max. Anyway, as always, thank you for watching.